Good afternoon, everyone. Yeah, good afternoon to everyone. Yesterday we were doing this question number 5. I guess we have completed this, and we'll start with the sixth question of the exercise. As usual, I'm waiting for 2 minutes for the students to join. Some are saying good morning. Now it's afternoon. Who is in 10th Blossom Saksham is also here in 9th class. Very good. No need to be here. You can go out. Okay. Yeah, good afternoon, everyone. Take out the next page in your book, exercise 7.1, question number 6. Exercise 7.1, question number 6. We're going to start now. See carefully on the screen now. I'm always waiting for 3 to 4 minutes for the students to enter in the class. So the minutes are over. Okay, look here on the screen, question number 6. The sixth question, AC and AE are equal. AC, the side AC, it is already marked. Side AC and side AE are equal to each other. Just wait for a second. Okay, now starting. I hope all are here now. So AC and AE are equal. See there, AC, it is already marked with these two lines, and AE are equal to each other. Fine. Then AB and AD are equal. Okay, AB and AD are equal to each other. Shubhranshu, whatever we have done, no, just do that. If I'll give you in the example, means in the assignment, any other questions, then you have to do those only. Don't worry for anything, Shubhranshu, okay? Yeah. Otherwise, you can contact me later on WhatsApp. Angle BAD and EAC are equal. Angle BAD, this angle, and angle EAC. Just see carefully. BAD from here to here, then EAC from this side to this side. Okay, and both the angles are separated by this space in between. This is the main point in the question. We have to show that BC and DE are equal. We need to prove that side BC and side DE are equal. I am marking them so that you should know how to see the triangle. See this side BC and side DE. Can you name the triangles in which BC and DE comes? BC comes in which triangle? B, C, then A. So BCA is the triangle in which BC comes. Okay, and DE comes in triangle ADE, or it comes in triangle CDE also, but this triangle, no, just neglect this triangle, C for this triangle, because things of this triangle is given equal in the given. Again, see, BC comes in triangle ABC and DC comes in triangle ADE. So that's why let me highlight the things. So one triangle is this with BC, because of we need to prove BC and DE equal, and BC and DE you can prove equal only if the triangles including BC and DE are congruent. So a triangle in which BC is present, that is triangle ABC. The triangle in which DE is present, that is triangle ADE. Now, wait a second. This is the other triangle. Now, how we can prove these two triangles congruent? Based on this, start writing. Given whatever is given in the question, just write as it is. AC and AE are equal. One more thing, AB and AD are equal. And one more thing, angle BAD is equal to angle EAC. I don't know. Students are not even aware which lecture is going on. Some are trying to enter from 10th even. So angle BAD AAC are equal to prove. What we need to prove? BC and DE are equal. Proof. Just take, just right here. Just look here. This angle and this angle are equal, no? So, and in between this angle, let it be angle 1. Let this between angle be angle 1. Okay, the angle present in between of these two angles. Now, what I am trying to say is start from this angle. Write that angle BAD and angle EAC are equal to each other. Why we are doing this, we'll get to know. BAD, just look here. Triangle which we have taken is this yellow triangle ABC. Okay, in this triangle, if you will see, this angle is not the part of this triangle. If you will take angle from here till here, then we can say that this angle comes in this triangle BAC. Are you trying to understand? This triangle is not a complete, this angle is not the complete angle of the triangle. Okay, so we have to take angle from here to here, which is angle BAC. Based on this, in the same way, if you will see this side, this is EAC. This angle is only EAC, but we have taken triangle EAD. Which triangle we have taken? EAD we have to take now. So that's why this angle 1, no, in between this angle 1, if we will add to this angle, it will become this full. Okay, and this angle 1, if we will add to this angle, it will become also a full angle. See again, if you have not understood, then see, this is an angle. We have to add this angle into this angle so that it can become a full angle like this. In the same way, this angle is given, we have to add this angle so that it can become a full angle like this. So we have to add this middle angle into these both angles. We have to add the middle one angle into these both angles, and let this angle be angle 1, the middle angle. Okay, so this angle I have assumed angle 1. Right here, BAD, which is this, is equals to EAC, which is this. Now we are adding angle 1 to both sides. Add angle 1, angle BAD plus angle 1 is equal to angle EAC plus angle 1. BAD, again BAD plus angle 1, this angle also. So it will become this full angle, which will be named as BAC. So here angle BAC, and here we can write angle EAD will be equal to each other. Try to understand the question, because next question also depends on this concept. So let it be equation 1. Now take those two triangles which I have shaded earlier. In triangle ABC, if I'm writing here, no, triangle ABC and EAD, then you have to look into the figure so that you can understand which triangles we have taken. ABC and EAD. In triangle ABC and EAD, we have this, first of all, BAC of this angle, angle BAC of this triangle is equals to angle EAD of this triangle. So BAC and EAD are equal from equation 1. This we have proved here. Second, what is given? AC and AE are equal. See this, AC is the part of this triangle ABC. AC is the part of triangle ABC, and AE is the part of triangle EAD. Yes, no. So AC and AE are equal. This is already given. AC is equals to AE or EA. This is given. After this, AB and AD are equal. AB and AD. See this AB and AD. AB is a part of ABC and AD is a part of EAD. So AB and AD are equal. It is right here. And this is also given. And because of these three reasons, we can say triangle ABC. Can anyone tell me which criteria is being used here? Okay. Yes, SAS. Yes, very good. SAS. There were two sides and between one angle. AB, AC, and between one angle. So this way we have to. So these two triangles are congruent. So by CPCT we can write that BC and DE are equal by CPCT. Hence proved. If something is not clear, then you can ask. The main concept is this: addition of angle 1 both sides to this given angle. You have a chance to ask if you have any doubt. Tell again, sir. Okay. The same thing, Preet Kaur, which I have marked here, this one, why we have added. Okay, Herman, I'm explaining again. Okay, okay. Yeah, I am explaining now. See this. Now concentrate carefully because you will be able to understand only if you will see the figure. Now, the figure is here and here only I'll write, okay, to explain you. First of all, see each and everything. They are saying AC and AE are equal. Okay, I am marking here. AC and AE are equal. One more thing, AB, AD equal. Okay, AB and AD are equal. I am marked. Clear? Then BAD and EAC are equal. BAD, it is already marked. BAD and EAC. EAC are equal. These things are very much clear to you, I know. But we need to prove here, see this, BC and DE equal. You need to see where where is BC present in the triangle and where DE is present in this figure. See, BC comes in this triangle. See, in which triangle it is present? BC, ABC. If I'll take triangle ABC, then only BC will come, no, there. Okay, so let me see where is BC. So this is right here. And the triangle which we are able to form with this is this. Is it clear? BC comes in this triangle. And where that this AC is present, this DE is present, and this DE is present in this triangle. See, okay, now you better know, sir. It means if we are able to prove these two triangles congruent, then we can say by CPCT that BC and DE are equal. Yes, is it clear till here? Whatever I am speaking, BC and DE will be equal only if these two triangles will be congruent. Say yes if it is clear. Then I'll move further because the main concept will come now. BC, okay, Preet, fine. BC and DE will be equal only if ABC and ADE will be congruent. Now let us see which are the things given in the question to prove these two triangles congruent. Which are the things given in the question to prove these two triangles congruent. See now in the figure. AC and AE are given equal. Just see AC. Yeah, AC is the red line comes in this triangle. Very okay. So I am writing ABC and one side I am writing this triangle ADE. Okay. Now let me see. AC is the part of, just check it out, AC is the part of ABC. Okay, fine. AC. And AE is the part of, see this blue line, AE is the part of another triangle ADE. So we can take these two sides are equal of these two triangles. Yes, this is already given in the question that AC and AE are equal, where AC is this red line comes in this triangle, AE is the blue line comes in this triangle. So both the sides of both the angles are equal to each other. It is already given. So we can write here, it is given. Next, AB and AD are equal. So AB comes in this red triangle and AD comes in this blue triangle. So AB and AD are also the part of two different triangles. So we can write that AB and AD are also equal, and it is also given. But the third angle, which is BAD and EAC, the third thing which is given in the question, is not relevant. See this, why it is not relevant. Angle BAD, angle BAD, no. If I am talking about angle A, which is the part of triangle ABC, it is angle BAC. It should be from here to here. Yes, no. If I'm talking about this red triangle, then which is angle A? From here, starting from this side and ending at the red line only. Is it clear? So it should be BAC, but it is given BAD. BAD is not the angle which we can take in this triangle. We have to consider angle BAC. This is clear that we have to consider this. We have to consider this angle. Is it clear that we have to consider this angle? Because it should start from the red line and ends at red line. So BAC, because BAC only comes in this triangle, not BAD. BAD is not the full angle. You can see carefully. BAD is not the full angle. There is a space here. You have to include this space also. And that is this middle one angle, which is angle 1, which we have supposed in the figure. Now see this. The angle given, the third angle given is not okay to consider in these triangles. And in the same way, see here EAC. Where is EAC? EAC. It is not the angle of this triangle. So that's why if this angle, the middle angle is added to this angle, no, it will become this full angle. And if the middle angle is added to this angle, it will also become the full angle. Yes, no, starting from the blue line, ending at blue line. It is also starting from red line, ending at red line. So these two angles we can take. Is it clear why we are adding angle 1 to both the angles? If you will add angle 1, this angle, it will become the full angle. If you will add angle simple, very simple it is now. Okay, so this and this are equal, and this is the middle angle which is required to be added in both the angles. If in this angle I am adding the one angle, it will become the full. And this is the angle which comes in triangle BAC. And if in this angle I'll add this angle, angle 1, it will become the full. So this is the angle which comes in EAD, and this is the angle which comes in BAC. So we have to add angle 1 both sides. So the third angle which is given here, no, that these are equal, that is not relevant. That's why we have started from that angle only, that BAD and EAC are equal. So add angle 1 to both sides. So we have added angle 1 both sides, and after adding angle 1, they will become BAC and EAD, which are required in the triangle, which are required as the criteria to prove. See this, these two angles were required from 1. And one more question, the same way we are going to do in the next, we'll be able to understand it better in next question also, when we'll do two questions similar. After that we can write. Just note it down, then we are doing the next question. Too much time we have consumed in the question. One more question let us do. Okay, Harinder sir, let me see. Hmm. Okay, Vanchika. Say this now. Question number 7. In question number 7 also, it is like this. AB is a line segment. Okay, AB is a line segment and P is the midpoint. P is the midpoint. Midpoints divides a line into two equal parts because it is a midpoint. It means this side of the line and this side of the line are equal. It means AP and PB are equal to each other. So this is given that AP and PB are equal. After that, D and E are the points on the same side such that BAD and AB are equal. BAD, this angle is equals to ABE, this angle. So these two angles are equal and these two sides are equal. Fine. And EPA and DPB are also equal. EPA, this angle is equal to DPB, this angle. So these three things are given and we have to prove that DAP and EPB are congruent. DAP, this triangle, it is clearly visible. DAP and EPB. So how we can prove that these two triangles are congruent? Are you able to see the three things in these two triangles? I am able to see this. See this in triangle DAP. Let me mark again in the same way. This is DAP and the other is this blue triangle, that is EBP. And in this two triangles, so if you will see the things equal, that are this angle of this triangle is equal to this angle of the other triangle. Very fine. So this will be able to take. This is all correct. After that, AP of this triangle is equal to PB of this triangle. So this is also correct. This also will be able to take. After, yes, very good, Aditya Jain. After that, this angle is given equal to this. See, this angle is not the part of this triangle. Are you able to consider this angle as a part of this triangle? This triangle, the red triangle, have only three angles. One this, and one this full. Not the half. Not this half. If we are talking about the angle APD of this triangle, then we should say this full angle. Yes, no? Okay. So this angle will not work. In the same way, see this triangle EPB. In this EPB, we have this angle, and third angle is this full, not this half, the black marked angle or this red marked angle. Yes, no? So that's why in this question also, let this angle be angle 1 and add this angle 1 to this angle and to this angle, so that it can become this full angle, so that this also can become this full angle. Fine. The same concept is being used in the previous question also. Is it clear? So starting with the solution of this. So question number 7 given. What is given in this? Angle BAD is equal to angle ABE and angle EPA is equal to angle DPB. After that, it is given that P is midpoint of AB. So we can say that AP and PB are also equal with this. Now what to prove? We need to prove two things. First, triangle DAP is congruent to triangle EBP. And the second, AD and BE are equal. Now, in the same manner, we are going to prove this. Proof. First of all, just write those two angles. These black marked angle. This it is given here. EPA is equal to DPB. Angle EPA is equal to angle DPB. Add angle 1 to both sides. So angle EPA plus angle 1 is equal to angle DPB plus angle 1. EPA plus angle 1 will become EPD. And DPB plus angle 1 will become this full angle EPB. Sorry, this is APD, I guess. This is written wrong. Wait, let me check how I've written. EPA plus angle 1. EPA plus angle 1. Okay, EPA plus angle 1, that is APD. This is APD. And DPB plus angle 1. DPB plus angle 1, that is EPB. So consider this first. Now prove in the same manner in triangle DAP and triangle EBP. In these two triangles, first of all, this angle APD equals to angle EPB from first. Then angle is not given. Now what are given? Okay, one more angle is given. This BAD and ABE are equal. This we can consider BAD and angle ABE are equal to each other. Given. After that, the third thing, AP and BP are equal. It is also given. Therefore, by which criteria we can prove that these two triangles are congruent? DAP is congruent. Yes, by ASA, very good. And EBP, they are congruent to each other by ASA. Again, we are using the same criteria, ASA. Note it down. Time is also less, means we have now still 7.5 minutes. Write it down. If you have any confusion in the question, ask that. Then we'll start with the next. Vanshika is asking, sir, if it is ASA, then side should be written in between. Side should be written in between. Side should be okay. Here it is written in between. Here you can write in any manner, doesn't matter. But you should follow the same here in this figure. Okay, see this angle, side, then angle. From criteria which you are going to see, no, that you can see from the figure. Now the last students are writing, sir, the last part is left, the second part. Okay, you can write here AD and BE are equal by CPCT. Koshima, Akshara, Aditya Jain, and others have written this. Okay, so AD and BE are also equal. These sides are also equal because of CPCT. Simple. Corresponding parts of congruent triangles are equal. So this way, question number 7 is also over. Yes, done. Okay, fine. Now, question number 8. Let's see how much we will be able to do this. Let me explain you first of all, what is this all about. Question number 8, in triangle ABC, see the triangle ABC, right angle at C, it means this is a right angle triangle ABC, where angle C is 90 degree. M is midpoint of AB. Okay, M is the midpoint of AB. It means M is dividing AB into two equal parts. So it means BM and AM are equal to each other. And C is joined to M produced to D such that DM and CM are equal. Okay, DM and CM are also equal. Fine. Show that AMC and BMD are congruent. AMC and BMD are congruent to each other. How we can prove that? First of all, write given. Start writing it. We'll be able to do the first part at least today. Given. So what is given? Angle C 90 degree. After that, M is the midpoint. No. Let us write M is midpoint of AB. What does it mean? It means that AM is equal to BM. After that, DM also given equals to CM. Now to prove. What are the things required to prove? Let us write it down. First, triangle AMC is congruent to triangle BMD. Second, angle DBC is 90 degree. Third, triangle DBC is congruent to triangle ACB. Fourth, CM is half of AB. So these are the things which we need to prove equal. Let us prove the first part now. See these two triangles AMC and BMD. It is very simple. In triangle AMC and triangle BMD. See in these two triangles AMC and BMD. In triangle AMC, AM is equal to BM of triangle BMD. See this AM and BM are equal as it is given. Because M is the midpoint, no, and we have explained here. See this, it is being explained here, so we can write here given. Then DM means CM is equal to DM. That is also given. And let it be angle 1 and let it be angle 2. So angle 1 is equal to angle 2. This is vertically opposite angles. Lavanya, you are asking angle B is equal to 90 degree. Angle B is not 90, that we have to prove that angle B is 90. So 1 and 2 are equal. So here triangle AMC is congruent to triangle BMD by, now we have used side, then angle, then side, SAS. Yes, you are correct. SAS, Raghav Gera and Aditya Jain, you are correct. So these two triangles are congruent to each other by SAS. Simple. So first is very simple. And with this, rest of the things I'll explain you tomorrow of this. Just write it down till here. Then we'll meet tomorrow and we'll do this question. And this question will take, I guess, again tomorrow 15 minutes. Then we'll start the next exercise tomorrow only. No new concepts is there which I have to explain you. The same concepts and we can do the full chapter. And keep in mind, triangles inequalities has been cut from your syllabus. 7.4 is not in your syllabus. So we have to complete this chapter till 7.3 only. After that, nothing is in your syllabus. Keep this in mind. Exercise 7.4 has been cut. So still 7.3 only. And 7.5 is optional for practice. Bye everyone. Take care. Bye.